So today I'm looking at greatest common divisor, or GCD. This can also be referred to as the highest common factor, which would be written as HCF. And it is the largest factor that two non-negative integers share. So what that actually means is the biggest number that will go into both of those non-negative integers. We can solve this in three different ways. We can solve by one, using an array. And I'll do examples of all of these when we get there. We can solve it by two, breaking it to its primes. And three, something that's called the Euclidean algorithm. So I'll do an example of all three and we'll see how that works. So one, using an array. So I'm going to go and I'm going to draw an array just here, and then I'll show you how we actually use that. Okay, so what I've gone and done is I've made an array, and what an array is it's listing out every factor of both numbers, up to that number obviously, and then we can see that this is the array for the number 48, 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8, and here is 64, 1 times 62, 2 times 32, 4 times 16, 8 times 8. And we look at this and we're looking for the greatest common divisor, so we're looking for the greatest factor they both share, and in this case that number is 16, so GCD equals 16. And the way we can actually write this is we do rounded bracket 48 64 equals 16. We do it this way because a rounded bracket a comma b means we're finding GCD. And you'll need to remember this for later because we deal with square brackets in another example. Alright, I'm going to go ahead and I'm going to do the breaking into primes method now. Okay, so hopefully what I've drawn here isn't all that unfamiliar to you. It is a factor tree we've been working on these. And we remember that when we do a factor tree, we then can list it out like this. 120 is equal to 2 times 2. Yep. Or 2 cubed times 3 times 5. And 260 equals 2 times 2 times 5 times 13. Or 2 squared times 5 times 13. So at this point, I've got both of my numbers broken down into primes. Now what I do is I take the lowest power of common factors, which in this example would be 2 squared and 5. Because in both examples there's 2 lots of 2 and 1 lot of 5. So it's the lowest power of common factors. And then I would write, therefore, rounded bracket, and our GCD would equal 20 because 2 squared times 5 is 20. Very final one I'm going to do is the Euclidean algorithm, and it works a little bit differently. I prefer this method the best. That's just me. Okay, so then we get to this example. I've used the Euclidean algorithm to find the greatest common divisor of these two numbers, 126 and 512. The first step I do is I divide my bigger number by the smaller, and I get that 512 divided by 126 is 4 remainder 8. Then I take this remainder of 8 and I go 126 divided by 8 is equal to 15 remainder 6. Same method again. 8 divided by 6 equals 1 remainder 2. 6 divided by 2 is 3 remainder 0. When I get to this point and I've got no remainders left, that is the point at which I stop. And I go back to the previous number I divided by, and that is my GCD.